Hello everyone, so in this video we'll be solving the question product of array except self. So this is a medium level question and the topics I think are array, hashing, all those array, normal simple array based questions. The question says that we have been given an array called nums and we have to return another array as output, where output of I is the index, is the product of all the elements of nums except num I itself. Each product is guaranteed to fit a 32-bit integer. Okay, could you solve it in O of n time without using the division operation? Okay, so let us look at a few examples. 48 is 2 into 4 into 6. 24 is x. Okay. mm-hmm. Okay, so the first and easiest approach is actually a brute force approach, order of n square, where we'll run two loops. For I, it will. So basically, if we are to imagine it, how the brute force solution would be. Is there no whiteboard software that is free? Online whiteboard. Do I have an account for this? Okay. So if we consider the array to be this 1, 2, 3, and 4, so how the brute force solution would be, there will be two loops. First, this is I and j, and the we will be calculating the product, keeping track of the product such that it will be equal to j. Product initially will be equal to 1, and now 1 into j for every loop. J is the second loop and I is the first loop, and we'll skip this calculation for the condition if I is equal to j. For this condition we'll skip this product calculation, because as the question mentions that we need to return an output array where the output of I is the product of all the elements of nums except nums of I. Then that is the reason why we are skipping like this. And the second solution as given over here is actually where we'll first initially, so let's code the second solution itself. Initially it is equal to 1. What we'll do is first we'll calculate the total product. See, in this there is one thing that okay, we'll talk about that edge case afterwards, but first let's calculate the total product. But in this total product, what we'll do is we'll skip, if I is equal to 0, this is the edge case, we'll skip this. If I is not equal to 0, that time only we'll calculate the total product. If it is 0, then we'll skip it. Now what we'll do is we'll start creating the output array So let us put like this. So for I is less than equal to nums dot size plus. Okay, so over here if else if so what we'll do is we'll keep a flag. We'll keep a flag initially just so let us name it 0 present. So if there is a 0 present in the array, that time we'll this as true, and we'll also keep a count of the number of we want to count 0. Initially will be equal to 0 and every time this is to here. Let's look at from -20 to okay. There are quite a lot of edge cases in this. Okay, so this solution of dividing actually will be very complex. Instead of this, is there another way? Is there another way? Let's take. I'm thinking of a approach where we use prefix and suffix arrays and store products. So let's do prefix product array first. Be 1 2 6 6 into 4, what is 6 into 4 is equal to 24, right? And now suffix wise it would be 4 into 3 is equal to 12 into 2 24 So okay, I think this will be possible. So for any number at a position I, it's this value would be equal to prefix this into prefix this into 624. Should be 12. So number year to year. For this 3 position it should be 8. How will we find 8? 4 into 2 8. Okay, I think we are getting somewhere. So for every position we need to find the product of this diagonal. This will give us the value of 2. For value of 3 we will have to do this. For value of this it would be what? It will be equal to 6 itself. If it's this, then we'll take this, and if it's this, then we'll take this one. Okay. So for your starting position for I equal to 0, we'll take suffix array of 1, and for I equals to the size, we'll take the prefix of size minus 1, and for others we will take prefix of I, if I is the position, prefix of I minus 1 into suffix of I plus 1 is what we'll be doing most probably. Okay, let's try to code out this solution. What we'll need is two vectors, vector and prefix product, and can we use this syntax like this? Let's find out. Both will be of, let's take another variable for size. Okay, now we'll need to run for loops. Let's do it like this. And then prefix product of I is equal to product. Okay, this looks fine. Just define a product over here. Start from 1. And reset the product to again, and use a similar kind of loop for the suffix product array. For this the condition will be less than equal to 0, minus have a decrement, then we'll start filling like this. This will of course be suffix product. Okay, so we now have this. Start creating the answer array. Let us fill the first and the last position. The first will always be equal to suffix product of 1, and last always be equal to, last will be equal to s minus. Okay, to prefix product of n minus 1. Is it n minus 1? N minus 2, not n minus 1, right? N minus 2. Okay, now start from the first index till n minus 1, increment it by 1 each and every time. Answer of I is equal to, what is the formula that we derived? Prefix of I minus 1 and suffix of prefix product of I minus 1 into suffix product of I plus 1. So answer, okay, let's just write one base condition over here, that if the size of the is 1, then we'll just return norms itself. Just return norms are 0. If it's true, there's a base condition, because our code over here will not work. This code that we have written will not work for a condition situation where the size of the array is equal to 1, because over here see, we are accessing I plus 1, I minus 1, so it at least needs to be of size 3 at least. So you'll need to write another condition over here, that if it's equal to 2, then the first one will be equal to nums of 1 and the second one equal to this. So apart from this, I think our code will work for all conditions over here. Okay, the minimum length is 2, it's given, but still it is necessary for us to catch all the base conditions. Okay, so we have our first array, suffix pro 54. Chalo, suffix product duct. Both cases not working. Might have to debug this code a bit. Oh shit. Zero 6 and 0 3. Why is it 0? Oh shit, it's nums of I. Silly mistake. Now let us try to run this. Okay, so both cases have been. Let us write a few other edge. Let's check for edge cases. For 2. It is running. Okay, for 3. Okay, it is running. I think this itself might work. Okay, so accepted. So this is the solution. I'll just reduce the so that it comes in one page. So basically what we have done over here is we have created two arrays, prefix product and suffix product, both of the size of the input array, and we have calculated prefix product, suffix products, everything, and stored it in this. And the base at these are the edge cases that for the 0th position and the last position we'll be substituting these values, and for rest other positions this is how we'll calculate it. And as discussed in the whiteboard, this is what it is. Hope you liked it. Thank you for watching. Please like, share and subscribe.